Okay. As good a place to start as any. In this first section, reminder, when you are trying to find growth or decay, now, could I plug this into the calculator and look at the picture? Sure. But again, when you've got 40 questions, I don't know that you've got the time to do that on every single one. So, if the value in the parentheses typically is larger than 1, that's going to be growth. If it's between 0 and 1, it's going to be decay, with one exception. If that exponent becomes negative x, that turns this value into its reciprocal. So like if this were 2 to the negative x, that would be looked down upon the same as having this mean 1/2 to the x, which would be decay. And there's actually a question down further, number 11, that talks somewhat about that. Okay, so greater than 1 is growth, 0 to 1 is decay, and I'll even pull that one up here. When looking at the function 105 to the negative x, Deanne thinks it must be growth since the base is greater than 1. Sensible, but incorrect. Is she correct? No. Okay, why? Again, here, this is like that last quiz we took. I'm not looking for there's a negative exponent. That's only part of the story. What does the negative exponent do? Yes. Okay. It takes your base and it turns it into its reciprocal, or flips it. Okay? So this would become 1/5 to the positive x, and now that it's between 0 and 1, now it's decay. But you can't just write negative exponent, because like I've said before, if that was a fraction in a negative exponent, it'd make it growth. So we've got to be really careful on how the explanation goes with that. Okay? Let's bring this back down a little bit here. All right, 6. What are we trying to find? The y-intercept, the shift, the domain, and the range. Okay. Typically, like let's say we'd have been doing 5, normally I can pick off my y-intercept by looking at this a value. So I'd say it was 0, 2. But I have a shift this time. What's my shift in this one?
Right one.
Okay, right 1. That's going to shift my graph right 1 to where that won't work as far as my y-intercept goes. So in this case, it may be wise for me to take a quick peek at what's going on here. When I'm going to make my exponent, since the -1 is in my exponent area, make sure you use parentheses. If you don't, you'll get something completely different. So when I look at this, and I say, okay, let me just look at the graph for a minute. Okay, it looks pretty normal. When I look at the table, again, my y-intercept, you kind of start to look and you're like, well, going through, okay, it's getting bigger. So where exactly is it going through y at? So I look and I go, well, not really sure. So let me look at the graph again. What if I'm not sure? What if it's not a value that comes up right away when I go to my chart and I don't see a 0? Here's an option. And for some of you, this may be something that'll actually make this go faster where I don't even have to graph it. Anytime you have a y-intercept, your x value is going to be 0. So what I could do is I could plug a 0 in here for x and figure out what this is. So if I plug in a 0 here, I'd have 2 times 4 to the -1, because 0 minus 1 would be -1. So let's see if it came out to some funky number, why I'm not seeing this. So 2 times 4 to the -1. Oh, okay, it wasn't a whole number. That's why I didn't see it. So my y-intercept would be 0.5 or 0, 1/2. So it may not necessarily always be on the table. If it's not, plugging in 0 might be an idea. Just for something to think about on that. The shift we talked about was right 1 because it's up in the exponent. Now these again are the ones where my domain isn't going to change. Okay, when we're talking growth and decay, your domain every time is going to be negative infinity to infinity. It's the range that can move. Now on logarithms, it's exactly the opposite. So here, for instance, right 1, because what's my range typically in any of these? Yeah, typically, without shifts, my range goes from, along here, 0 to infinity. So that would be the case here. I don't have an up or a down shift here. So it's still the case on this one. Even though I had a shift, it's not up or down, and that's all that would affect my range. But if I use that same theory here with number 7, what are my two shifts in number 7?
Down 3 and left 2.
Okay, so left 2 and down 3. That down 3 affects my range because now instead of at 0, it slid down 3. And that would change my range. Okay. So on growth and decay, the only thing that's going to switch my range is an up or a down shift. Domain's not changing. Never, 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 ever. Ever. At all. Anytime through this week. That'll work on the last quiz.
So when you're looking for the Y-intercept and it doesn't show up, you can just use 0 for any of them?
Yep. Yep, that'll work every time.
0 is always the first letter, but it's the Y-intercept, right?
Yep. So I mean, like if you even were, let's say you were looking at 7 and you were like, okay, I'll just check quick because I might be able to do this a little bit quicker. And I'm looking, I'm going, ugh. You can always go, like I said, and go plug that value in if you don't see that intercept right away. But here, we've got one. It's pretty straightforward. It's right there. It's a 0, 1. So that was kind of nice. And I think I boneheaded. I think that could have done the other one too. But it's nice having multiple ways of doing it anyway. Yes, ma'am.
You do number 16.
16. All right. Let's talk a whole section here at once again. These are the ones on the last quiz that were killer. Why were they killer? Because it's not a problem that we use change of base. It's understanding how we get there. So let me go actually 16 through 19 here. On these, like I said before, I don't mind if you use change of base, but I want you to set them up exponentially first. So for instance, on 16, it's always base. That's going to be my exponent. That's going to be my answer. Now, if you can look at that and figure out 1/3 to what power is 27, great. Go ahead, figure it out, get your x value. If not, at this point, now I can take this and use change of base, which is the log of my big base, not necessarily the larger value, but the 27, and divide it by the log of my subbase. So it is absolutely acceptable at this point. You get out of here.
Can you always do that?
Yes, anytime you have anything with a logarithm, you can always use change of base. But like I said, the one thing you want to make sure of is that you're showing how to get there exponentially first, and then I don't mind if you use change of base to get to the answer. Okay. The only one down here that's an exception to that is number 15. Because number 15, I see an inverse already. 5 and a log of the same base cancel and just leave me what's left in the exponent. But any other type, any of the rest of those 4, you've got to set up base, exponent, answer. Then you can go to change base. So again, I just want you to be able to make that switch back and forth on these.
What about 14 or 13?
Okay? Those literally just plug them into the calculator.
Give you guys 27.
Which one?
27.
All right. Condense the expression. Okay, before we go condensing, reminder of the rules. First thing we're looking for when we condense is coefficients. If we see any, those are getting swung around and becoming exponents. Once I've done that on these, if I see any addition, that turns into multiplication. If I see subtraction, that turns into division. We're just using rules like when we were doing exponent rules. Same idea. But I really want to do them in this order. So if I'm doing 27, I see 2 coefficients. So I'm going to swing those both back up to their rightful place as exponents. So I've got log 9 to the 1/2. And I'm not going to do everything at once here yet. So I'm still going to leave this as plus. Cubed minus the log of 8. Okay. At this point, since they're values, okay, not variables, I can actually figure out the values of these things. 9 to the 1/2 is just another way of saying square root of 9. So the square root of 9 is 3. 4 to the 3rd power is 64. And log 8 still doesn't get to do anything. Almost. Now I can start putting this all together. So at this point, okay, I've got my log.
Is that equals log of 68? Or no, we subtract.
Yep, just to subtract. My plus becomes multiply. So here I've got 3 times 64, and the minus becomes divide. And all I'm going to check for at this point is if I simplify it, will it simplify more? So like 3 times 64 is 192 divided by 8, and that is going to simplify to the log of 24, and I'm done.
Do we have to like do two exponential form or something like that? Like if you give us log 24, then we have to get into that, right? 1.5 times.
Yeah, I'd want you at least at a point like this, I'd at least want you to get to like here, let's say, just so I can see that you're understanding that it's turning it into an exponent and that you can kind of condense it down some. The further, the better. Yes, ma'am.
Will you do like 31 and 32?
Okay.
Can we go? No, I was kind of confused on like number 17. On those people.
All right. I'll head to that next.
I was paying attention.
Sure. All right, 31. Solving equations. We're talking inverses. So remember, E and natural log are inverses. And any value, I'm not just saying it's a variable term, any value and its log of that subbase are inverses. So if I'm doing 31 and I'm working on getting to this x term, natural log's in my way. So I'm going to use E to take care of the natural log portion. Now at this point, I'm not punching e to the 4th into the calculator yet because I'd have to round, and if I round now and I round at the end, I'm going to be rounding too much. So my last step here would be to divide by 8 to get x alone. Now is when I want to go ahead and type it into the calculator. And again, E is just going to be second natural log, second ln. Make sure you close your parenthesis on your E.
Is the same for number 14? You use the E for now on.
I'll peek there in a sec. If I had another, I don't have another one in front of me. And again, here, depending on how many decimal points did I go to, we went to thousands, okay. But that's how that one would work. People haven't forgot, I jotted down 14 here. We'll take a peek at that in a sec. But then 32, before I can do anything with these, because some of you are going to look at the X and you're going to go, ooh, I'll just log 4. I need the same base here. So if I'm looking at 4 and 16, well, I will be in a minute here. If I'm looking at 4 and 16, what can I do with 16 to turn it into a base of 4? 4 squared. So I'm going to convert 16 to 4 squared. Well, and here, basically my next step would be to be log subbase 4, because then I'd wipe out the 4s. But since I already know I'm going to do that, I can sort of at this point think that I did it.
Okay.
And then I just take the exponents that are left. Again, I've got to distribute here. And then I can just solve the equation that's left. Because basically all I'm doing is setting the exponents equal to each other. I had to distribute the square through because my exponent rules say if I go power to power, you multiply them. So I'm multiplying the 2 times the 2x minus 3.
And then going back to that one, 17.
That's where I'm headed. I'm just peeking to make sure I don't have any other writers going on here before I go flipping along. Yes, sir. Okay, I'll come back. I'll keep myself a list going here.
Can you look up for 14?
Yep, 17 and 14 is where I'm heading next year. I'm just making sure I don't have anybody still writing here because I don't want to lose people there.
What I did was I put a 10 in front of the log 10.
Yes.
So that canceled that out. But then how do you get that 10x?
You could. Actually, you could. On 17, you can either, the natural way to turn it into an exponential is that this will always become my base, this will always become my exponent, and this will be my answer. But what you'd mentioned would work if, and then I can hit both of these at once, if I were to say, okay, I'm going to look at it as though I'm doing this, and then I just said 10 to the x equals 1 over 100, what would that be? Well, it's negative 2 because 10 squared is 100 and I need to flip it. That absolutely could do the same thing. But if, again, if you're not sure, going to change a base and just doing log of the 1 over 100 divided by the log of 10 would get you to the same place.
And then on number 16, how do you do that one?
Same idea. Once I put the setup, I just took the log of my large base divided by the log of my sub base. I'm just using change of base form on them. Yeah, I'm not trying to do anything fancy. And then as far as 14 goes,
The Ellen, right? Ellen, right?
for which one?
For 14.
No, I'm just plugging that in as I see it. There's no equals. There's no equation to solve.
For E, though.
Second, yeah, second in ln.
Oh, yeah.
Okay, I thought you were meaning we were trying to do an inverse, but yeah, second in ln. Yep. Yep, that'll do it. So hang on here, I'll keep. Yep. And I see I've got 30 on my future list. Yes, ma'am. And 33. All right. All right. Let me shrink this. Let me head back to this other page where we got 30 and 33 at. All right. 30. Now, the same way that a log can cancel out a base can cancel out a log. So for instance, I'm trying to get x alone. I have log base 5. The inverse is to exponentiate. In other words, these both turn into exponents. The log and its base will cancel. And this is 5 to the 4th power. It's not 5 times 4. So 5 to the 4th power is 625. Okay, that's different than, let's say, 29, where you're like, well, I see that that's the base 5, so I'd use a log of that same base. That doesn't turn them into exponents. But I have to do to one side what I do to both. So if I do log 5 here, I have to do it here as well. And then I can just use change a base. So log of 16 divided by log of 5. Okay. If, that's a good question. When does log of base 10 come in? If it just says like log of 16 here, that's when I assume this is 10. So like in this case, I'd do like a 10 to each side on that one. But yeah, only if I don't see a log on that one. Yep, 33 is coming. Okay. Okay. All right, so 33 and 35. Whatever's up over there. 1.723. So here, before I can deal with the log, there's something in front of it. There's a 2. So my first job is to take care of that. Now, since 3 halves, if I punch that in the calculator, it comes out 1.5. It's clean. If you want to go to the decimal on that, you can. Or you can just leave it as 3 halves. If this were some ugly decimal, like 0.82376, something like that, then I'd want to leave it in the fraction form for right now. But it's interesting that we just talked about this log 10 thing, because we get to use it right now.
Where did he get the 1.5?
3 divided by 2. Here, remember, if I don't see a subscript, a subbase, that's assumed it's 10. So similarly to what we did up in 30, I'm going to use a 10 to exponentiate what is going on. In other words, the 10 will take care of this log base 10. And I'm going to take up some space in 34 here. Notice, though, I didn't plug in the 10 to the 1.5 and put the decimal down because I don't want to round until I have to. So my last step here would be to add 44. Now is the point where I can go to the calculator and say, okay,
How many units are we getting this semester?
4, I believe.
Did you put 10 to the 16? Oh. It's 10 to the 1.5.
And then that's where our answer would be coming from on that one.
Wait, is all that?
Yes. Yeah, this is all. Make it clear, that is all 33.
Okay, next.
About 35.
Okay. So then, 35, we're looking at the same thing. Part at a time. Oh, 34 I can do in like a half step. I can do it right up here if we need to.
Oh.
Here, I've got to work away at isolating. I want to get to the natural log of x because then I can just use e. So I'm going to subtract the 1 first. So that would get me to -5. I still can't get to ln because I'm multiplying it by -2. So I'm going to divide by -2 to both sides. And -5 over -2 would be 5 halves. Or again, it comes out nice and clean so I can go to the decimal. Again, if it didn't, just leave it as 5 halves. Once I get that natural log as the last thing separating me from x, now I can use e. Again, it exponentiates it.
So you do the half of 5, which is 2.5.
Half of 5, which is 2.5, And then I just plug in the e to the 2.5, and that's where my decimal answer would come from.
So what about the negative starting? What was the negative 5?
Right, but when I divide it here, negative 5 divided by negative 2, negative divided by negative is positive.
See, when I did it in the calculator and I did the negative 5 and the negative 2 and I didn't do the 2.5, I got it up.
Let's take a peek. All right, let's see what's happening here. Let's see if I poked in something funny. Whoa.
Yeah.
Did I miscopy something? Let's see. Oh, that's what I did.
Give us the wrong answer.
Yes. I know.
Now I'm all confused.
I know.
Just kidding. So that's this one.
So which answer did I copy over there? I don't know what answer I copied over there. Yeah, I know. I'm just looking over there trying to think of where I got that from. I think I know where I got it from.
Where did I get what is that? That's what we just did.
Hee hee.
Mr. Carter?
Yeah.
I forgot what I was gonna ask. Oh, how many decimal places do you have to go?
When in doubt, go to 3. It might tell you to go to tenths. It might tell you to go to hundreds. It might tell you to go to 10,000s. If it doesn't tell you, just go to 3. 42. I'm circling.
Are you working on a problem next? Or
Yes, I can go anywhere I want.
okay. So, 9 and 4 10.
All right. So right now we've got requests. Let me just see what I've got a little bit of, just to make sure we're hitting a little of everything here. Okay, 36. We can handle that in a minute.
42.
42. I know. I'm just looking to see. All right, we can handle that.
So how do you 38?
And 41.
Okay, I now have 6 problems. I'm stopping for a second on.
You got 36, right?
Did you do 41?
Yes. Yeah. Just stop. Oh my gosh, I'm feeling like I'm in school with my nephew right now. Hang on. Yes, because I was going to say I'm going to go. I will get through all of these. I will.
What's the hardest
Determined to stay cool and try. Well, no, I'm going to get to all these. So again, I will get them. So if yours does not come up right away, do not start asking me. Are you good? I will. I'm actually going to go to the front and start working my way back. So okay.
I got number 8 correct, so then I went to go do 9 and 10 and 9.
Okay.
Yeah, I didn't see number 9.
The thing I'll mention on 9 when we get there is, if you're going to go calculating, which I'm going to assume most of you would, couple of things. One, I want to make sure the 1/3 gets into parentheses, because that could change things a little bit. And then the other thing is, I want to make sure both my x and the +2 are in parentheses, because if I close the parentheses on the x and then do +2, that would be more like number 8 was. So when I get here, let's take a look at this. Okay, so we got our growth working here. All I would be looking for right now is kind of looking here saying, okay, where are some points? Let me get an idea here of, for instance, I know this shift would left to, so that's not going to change a whole lot. So you start to look and you're like, okay, where are some values I can work with? So like 0, 2.46, okay, I can work with that. 1 is going to be a little over 6 here, okay. And I start to look at the other values. And I'm like, okay, so -1 is almost to 1. And then it gets really, really small. Now I look at the graph and it's like, you know what? It's going to hug the asymptote at y = 0. So I want to make sure that I finish it and I get that arrow, but that I'm not going through the x-axis in this case. So just use the points to help, But then again, you're just kind of using the table to kind of get you a general idea on that.
Do you always use ln for e?
ln and e are always inverses of each other. Yep. So that's kind of where we're at there. And if we do, we'll come back for 10 here in a second. I just want to make sure we hit a little of everything here. All right. 28. Inverse. Switch x and y. Solve for y. Well, the only thing that keeps me from solving y is that I have this log there. So again, we will exponentiate.
What number? 20?
Yeah, it's 28. I'm sorry, let me move that down a little bit. So the 4 and its base cancel. And I've got y equals 4 to the x power, not 4x. There's a difference. And that's it. One step and I'm basically good on that one. That's the answer.
You keep it there.
What about the 4x?
Yes.
This is 4x.
This 4x? That is, that's the inverse. Once y is by itself, I don't have to try and get x alone here. I just had to get y by itself. Yeah, in this case, x is the exponent because I'm exponentiating. Every time I use something to get rid of a log, it turns everything into an exponent. Now, 36. Here's the dilemma. Let me shrink this for a minute. Read carefully. Population of a city in 1985 was, here's this number. So let me use that. That's my starting value.
You underline decay.
I did for a good reason. Population was growing, 1 plus 0.04. Okay. Now, per decade. How long's a decade? 10 years. So if I'm going from 1985 to 2005 by decades, how many decades have passed? 2. Okay, if you use 20 thinking, oh, it's 20 years from 1985 to 2005, you're going to be off. So you're just going to plug this in the calculator as is. And I believe that will be the population that you will get. 1,380,000. But the key there is to read that it's decade and only use 2 for your t, not 20. Ooh, big difference. But otherwise, the formula will be there, so it's not like you're going to have that memorized. And then you're just going to plug the value in and just read carefully. And that's kind of how that one would work.
What if there's like an E in the system for like
What's that?
like when you graph it says that, but then instead of 0 it has E6.
It just means there's 6 decimal places after that. So like this would be like 1.38 times e to the 6th or 10 to the 6th. It just means my decimal would point here and I'd start counting it out.
Oh, I thought it meant like after the 8 there's 6.
Nope. You did. All right, quick peek. Oops, no, not x, not x. 2. And again, depending, it's going to depend because I think when we did this first hour, they made me do it in the y equals table. And when you did it in the table, it came that way. So if you went table, it would be about this. If you went with your actual value not going in the table, you'd have that. Yeah, it's just, it would be a rounding issue there. Either works. Either would work.
On the board, you have it to the x power instead of to the second.
That might explain it. That would explain it. Yep, because then it meant we went to the table on that. So we definitely want to change that up. How am I doing here? I'm doing fine. Okay. 38. Paycheck. An account. 3.5% annual interest compounding continuously. How long until your balance triples? Notice they didn't tell me what I started with. So I can make my P anything I want. So let's say I make it 100. Nah, 100 is fine. So 100 E 38. I don't know how long the time is yet. But if my balance is going to triple, at the end I want it to be 300. Now I understand I can't type that into the calculator that way. This is going to be what I end up typing in. Or if you did $10 or $1,000, this value for you may change, but then this value is going to change with it. So let me get this out of the way. So if I go to plug this in, get my E working here, 0.05x. Okay, and I have to have the x with my 0.035 because that's going to let me see in the table how long it's going to take for this to keep increasing. So if I do my table, remembering I started with 100, now if you start to go and you're like, this is going to take forever, well, it's not going to be too bad. I could always change my table. Okay. So what do we got here? 331, 32?
I got 4 between 3 and 4 years.
Nah, wait a minute.
I don't know what.
What? Now I'm getting irritated.
But you could have started with a different number.
I still should be getting the same no matter what, because watch this. Let's say I start with $10. For me to get to 30, I'm still in that 31 to 32 year ballpark area. Bailey's going to change it because I'm wondering if I copied off the wrong. Oh, I'm not going to say where I got that one from. I was looking at something else when I wrote that up there. Now I know what it is. You'll find out later. 31 to 32.
42.
Oh, wait a minute. Which one? Depending again on if you went to the chart or did it manually, it might be off that couple.
I just have a number 34. Instead of like you have to do the whole problem, but how you would exponentiate the 5?
Yep.
Do it to both sides.
Yep, because that's all you'll end up with then.
Okay.
842. Which one? 42. Let's bring that up. 42, basically, we are going to put both of these in the calculator. So that first function, they give you two functions in there.
Is it the same thing as 0, 1, and 2, and 3? You add all the numbers together?
Not on this one necessarily. It's going to depend. Because here,
Why is it count 1 called count 1 and then the second one count B?
because I just try to be difficult.
That would confuse me.
All right.
Last hour did this problem, Mr. Hardy?
They did. Yeah, this showed up on the first one. So when I go to table this, okay, I'm going to answer the second question first. Better long-term investment. So I start looking, and at the start, I'm sort of looking going, okay, the first one, account 1 looks like the better idea. And then I keep going. And when I start getting out to here around year 11, year 12, now what happens? The second one gets better and better and better and better. So which account's better? B.
2.
Or 2, better interest rate. for them to have the same balance, you're going to want to just check and start to see, okay, at what point does it change over where one's better than the other? You start to look, and then I can laugh at this. No, I'm just kidding. You start to look and notice here, the first one's bigger than the second, but then now the second one's bigger than the first. So somewhere in this period between 11 and 12, they had the same balance. So that's how that one would work. Some of the other graphing type ones, they did more in first hour. So if you want to look at some of those other ones or some of these story types, that'll be more helpful to you if you want to see some other.